And we are live or whatever. All right, so tonight we are going over chapter 9. I think that's right. Chapter 9 of Refactoring by Martin Fowler. This is about organizing data. So all the data, I guess data structure refactorings is the best way to characterize them. It's kind of a short chapter for me, so.
I don't think you're recording. Are you?
You don't think I am? It says I am.
Oh, okay.
Okay.
I didn't receive that.
Okay.
Sorry.
Don't say anything inappropriate, Antonio. We are recording. Just kidding. It's a joke. Okay. Yeah. So anyway, it was a short chapter, like super short. So I don't really have too much, but I'm hoping one of you has something reactionary to say. Otherwise, this will be a very short discussion.
I'd say any man that chooses to illustrate a software principle with haggis deserves a round of applause.
Nice. Is that all we got?
That haggis piece should take about 30 minutes to cover, right? Because like I don't even know what a haggis is. I'm going to go look it up separate. I think I know. I think I've seen it on a plate once.
So I'm not Scottish, so I can't speak definitively to it, but it's probably something you don't want to know.
Yeah, don't eat it.
But yeah, there were only 5 refactorings in this chapter, so it was pretty light. There isn't a lot to cover, right? You could read the whole chapter and that would be the hour. I did a little, I don't know, I don't want to call it self-study. I thought both of the reference pieces were interesting because I don't really use references frequently in my own code. And I'm not sure why that is. I think I'm sort of like inherently opposed to them because I'm not sure that I know the right times to use them. And so seeing those examples for like, here's when you would like change it from one to the other, it didn't necessarily resonate with me because I wasn't necessarily sure like, well, when would I want to use a reference to begin with? And how does it make it easier to understand code in certain situations? And so I did like a little exercise on my own where I just popped open my code editor and I was saying, hey, I'm going to just like write some inline code where I'm going to use a reference and then sort of like re-familiarize myself with what happens, which is just sort of like something sort of secretly happens behind the scenes where you call your function and some data you assign somewhere else, now you could change it. It sort of like breaks that concept of immutability if you don't want to be changing things very much. And so I don't know, I got kind of hung up on that on those sections, even though it was like a short chapter and a short thing, because it raised other questions for me of like, when would I want to use these versus, it makes sense. You don't want to have like 5 objects. That was what he said, like, oh, in the customer case, like now you've got 5 customer objects in these orders. But the bigger question is like, how did you get in that situation to begin with? I guess I didn't really understand the example. So if anyone else wants to enlighten me, I would love some more chatter about that in particular.
Yeah, I think the problem is usually not, there are very specific situations in which you might want to like pass an array by reference so that you can modify it somewhere else and that gets replicated on the caller. But I think what's most insidious is that you do use things by reference and you might not even know that you are. So if you use an object in PHP is by reference. If you generally some dependency injection containers just keep one copy of the object that got created. And so that one gets passed around as reference. And so I think usually what catches you is when you don't expect it to be by reference, but it is. And that's when all sorts of chaos can ensue.
I agree with that. I think so when he was talking about changing reference to value, like the example he was using with the telephone and kind of making the case for when would you want value objects and would you not want to be reaching into something. So like, I think the rule of thumb, aside from the, explicit passing by reference to do like array manipulation in PHP, for example, or something to that effect, but more on the hidden side where you've got some object which holds another object inside of it for whatever reason, like it's a property, and then you're manipulating it through that first object. Like that's what you want to avoid, I think, most of the time. And so that's when that particular refactoring comes into play. Is now instead of, hey, I want to update the phone number, and in order to do that, I need to know from the outside, like I'm updating a customer's phone number. So I say, customer, your phone number's area code should change to this, and that's not the actual behavior that you're wanting to do. You're wanting to say, replace this phone number, which is a distinct thing. Like you don't ever, or I guess if you're like, you want to ever like replace a phone number in pieces, like you wouldn't say, today I'm going to change my prefix. Like you just have a different phone number, like so you give it that way. And I think that's kind of that's what I took out of what he was trying to, or when that would be applicable, is when you're seeing something that doesn't make sense because you're reaching inside of an object inside of whatever you're doing, and then you want to change that particular behavior or mechanism, I guess.
I think also the ordering customer example is pretty clear. Like if you have that very clear relationship between an order and a customer that made that order, and if that's a one-to-many relationship in which the customer has many orders, if some customer information changes, you don't want to have to like go across your whole system, maybe not even that, but if you're, I guess on the web at any point in time, a specific copy of that order could be floating around in memory on somebody's request response kind of flow. So how are you going to update those? I mean, if it's like an email or something, it might not be that interesting, or maybe it is, right? Like the email change and now you need to send a modification, and one of those threads, it's sending an email to some random email that is no longer valid because that copy did not get updated. So I think the whole thing about copies, like what things, I guess kind of like the whole active record thing, like what should truly be active records all the time, like what things need to be modified, from like a single source of truth, whether that's storage or something in memory or however you manage it. I think that's where things get complicated. And I also got very caught up like you, Jeremy, on that whole part of the chapter, because even though in my brain, I kind of feel like I know what the heck immutability is about and why it is important and some of these things, at the same time, I'm like, there are like so many layers and I don't really know in like the specific scenarios and like when I should watch out for it, and when, like some people are like active record is awful, don't ever use that. And I'm like, okay, so what did you suggest? How do I solve that problem about the single customer that is the source of truth? And I want to know everything and I need everything to be synchronized across the customer information. How do you solve that? How it's, yeah. So it's, I still have a lot of questions that the chapter definitely didn't go into any detail about any of those things.
Yeah, I thought the change value to reference section where he creates this repository then, and he kind of digs deeper and says, well, you're still kind of reaching out, right? Like you've still got the situation here where it's not resolved through dependency injection yet. So he didn't go through that extra step of like, yeah, I'm going to actually pass in the repository in here, so that it felt like he left it with additional problems instead of kind of showing what that full refactoring would be, even though it was clear that, okay, yeah, this solves the problem of not having duplicates of the same like value. But it just left it, it was just left a little unsatisfied then, because it was like, okay, well, there's still a problem here. This is just a different problem, and where is that going to be referenced in this next chapter or something? I don't know.
Yeah, Jeremy, I came across that too, but I think right at the end he saved himself by admitting that that's a subtle issue that you should probably take care of, because I thought the same, like, okay, you're doing this, but now you're introducing this dependency, and I mean, that's no better, it's no cleaner, you're still gonna have to refactor. But he kind of saved himself. I thought, I'm gonna give him crap, but right at the end he said something. He didn't show you how to do it, but he said, yeah, you're probably gonna have to take care of this, so beware, I guess.
I guess maybe the value in these two, actually, before I say that, the funny thing about this is this almost goes back to implementing domain-driven design, like this conversation about when is a thing of value and when is it an entity in domain-driven design speak. But the thing I got out of these two refactorings was that frequently, I don't know about you, but I'm going to assume we all do, we see code where someone has something that really should be immutable, but it's a reference. Or somebody has something that's treated as a value, but it should really be a reference in these cases. So the value I got from these two was just understanding, if I come across these cases in code, what are the steps I would go through to resolve that situation? I totally could take your points that the deeper things about, when is a value the right thing, when is a reference the right thing, weren't really dug into a lot on those two. But I wonder if that was intentional. Like, he didn't call out specifically, I'm not going to have a long discussion about this, but I wonder if he deliberately sidestepped that and just presented the mechanics here.
Yeah, to me, Jeremy, it actually spoke a lot about knowing what your programming language does by default, like which values, which things are going to be passed by value, which by reference. Can you override that? Because I know, for instance, in C#, you could be explicit. You could say, I want this passed by reference, despite what the default is, right? So knowing that, I think, helps. Otherwise, you might have these subtle issues that you're not aware of. Because I'll admit, I don't think about this much either. Now seeing these refactorings, like, oh, I really should think about this. I really should know, because you might run into problems later, especially if you want to change these things.
Yeah, I'm definitely going to be looking out for this. So like maybe it sticks in that way, because now anytime I see something in my own code that's using a reference, or when I say my own, I mean like my works code, stuff I work on, because I know it's out there in the wild. I'm like, oh, we're using a reference here. Should it be? And vice versa. Like, oh, maybe this might be a case where, are we making 5 objects? Toward that end, like, I mean, yeah, that'd be maybe a conversation I'll have separately offline with Jeff about like tools about how do I find out if something's making multiple copies of something. That'd be an interesting thing. See what's out there.
I don't know if I know of anything that does that for you. It would have to know. It'd have to know a lot about your code. It'd have to understand, like, hey, you're instantiating an order. You're instantiating orders on all these places, or you're looking at customers here. Like, you'd have to understand a lot to be able to tell you, hey, maybe you should think about this.
Mm-hmm.
I guess computers can't program for us after all. The customer order example was just, it was getting to me because I've dealt with situations where, like, in like the same principle where you're like, oh, I have like a bunch of orders belong to a customer, and then over like periods of years they've made dozens of orders, and now you've changed the shipping address associated with the order or with the customer. So now, like, you're like, which orders went? Like, I can never reconstruct an order because someone has been like, I'll optimize this so that we don't have to have 10 copies or store the data with the order or whatever. And it's like, no, actually you want to, unfortunately, in those cases. So it's kind of like I was just sitting there reading it, trying to think, okay, he's talking about in memory, in process, like right now, not over a time period. So yeah, just a little fun.
You're getting into temporality and data, and that's a whole another nightmare that you don't want to go there. Trust
no,
us.
I do. I want that. What is that database theory of like
oh my God.
databases, so you can reconstruct what something looked like, at a time period. That would be so much fun.
Yep. Actually, Martin Fowler's got a really good article on his website about temporality. If none of you have come across, if any of you are interested or you haven't come across those concepts before.
If you are interested, stop being interested, because it's just going to hurt your head. That's my advice. Sorry, that's not good advice. Yeah, I did. So the one thing I wrote down was when he talked about replacing derived variables with a query. I really liked his example that, like we talked about this, I think last week, but the methodology, like a lot of times I'm tempted to just kind of gloss over it because it feels very repetitive. But I did like when he talked about, hey, I had this, hypothesis, and in order to verify that I could replace that with a query or with a function call, I'm going to put in an assert statement and verify, like, I can actually assert that this is true, that my assumption is correct. And then he took it a step further and said, now I'm going to make the method and defer to it and then verify that that works. And then I'm going to replace it in the caller. And then I'm going to finally pull inline the function that I wrote and just delete it. It was like, I thought that was really kind of cool. And like, I know I probably said this last week too, but like I really need to, when I approach some of these, just kind of go through the methods step by step and just see like how that feels instead of trying to skip ahead. Because I think there's a lot of value, and you probably learn to see things differently by doing it the way he's describing in the book, I think. So, but yeah, that was my one thing that I took out of this chapter was it was a really good example of like how the methodology could be helpful in just verifying that you're doing the right thing. Like that first assert statement, if it fails, and he talked about like, if that fails, then I was wrong and maybe I need to look somewhere else. And so I thought that was kind of cool. Like just thinking about it that way. Like we always talk about like, unit tests or tests outside, but you could literally just, that's like a 2-second verification that you can do with a debugger or whatever tools you have available to you and just check it. So I thought that was kind of cool.
Yeah, that part stuck out to me too, because I find I can't remember the last time I used an assert statement in code to actually do that kind of verification. So it was kind of a reminder to me like, hey, this is a tool that I could use, and it just makes things easier to check rather than trying to rely on my gut or relying on understanding, what is the typical data that's being passed in here.
I think the last time I used asserts was when I was taking like computer science 112 or something, and they were like, this is how you set up all your functions, and you put these asserts. I was like, oh cool. And then you go like do real programming, like, wait, there's no asserts at all. What are y'all doing? Y'all don't do this? No, nobody does that. Only in academia.
Well, our version of asserts is we make all our data JSON, and then we use JSON schema at every single connection point, which is probably even more crazy than just using asserts. So
that's one of those things like they, talk about, like if you ever want to find what's hip and new next month, like you should go look at stuff from 20 years ago. And then, so it's probably, we've gone to the point where now we're validating with JSON endpoints and validating like JSON schemas, and we're going to circle back to assert statements next year. So you heard it here first. You're prepared now. You know, let's get on that.
Tables and markup. Oh yeah.
Oh boy. We're going there, huh?
So right now, I'm doing some new piece of code, and I'm actually, so first try was, okay, I have this temporary variable that I'm going to use immediately here, and then later on 3 or 4 experiments later for another function as parameter of another function. And I was reading this and say, oh, okay, we can use this to replace the right variable with query, right? So I did that, and the code certainly reads better, but I'm still feeling a little bit guilty of, okay, this might take 2 more nanoseconds, right? So yeah, that's kind of my main issue with anybody can argue, hey, this is less efficient, right? And if we start multiplying this everywhere, at some point, it has an impact.
It certainly feels that way. I'm with you. Every time I do it, I'm like, this is, it's like against my nature at this point. It's like, I cannot do this. We talked about that with the, loops and running over, iterating twice. And I think just, if it reads better, it's understandable. That's the goal. That's the primary goal. If you notice like yes, you're absolutely right. I think that, over time, all those milliseconds add up. Of course they do, but like address it when it is an actual problem, like not when it's that there's going to be a bunch of that going on. It's like, when's the right time to address it? When you actually see, requests taking too long, or depending on your context, like something is spinning, or you're having issues with concurrency, or whatever it actually affects something. That's when I would address it. I wouldn't. It's hard. Like, I'm not going to say it's easy. Like every time I'm like, oh, I've added 15 variables in here because I was using that same thing, and I've taken them out. Now I'm calling the same method 4 times, and it doesn't make sense. But that's like to me, that's a smell, or it could be a smell at that point. Like if you're optimizing inside your code by storing things in temporary variables, maybe there's something that you're doing that's wrong in that capacity. So I would start there. Like I I would worry about the milliseconds until they're actually costing you.
I do feel that as well. Like in my gut, it's like, oh, but this calculation's happening multiple times. Isn't this more inefficient? And I always kind of counter it by thinking, well, if it's 2 extra nanoseconds, I mean, this has to happen like 500 million more times for it to add up to a second, right? Like it has to be, I have to do this bad thing 500 million more times in the code. And like, how many more times am I actually doing it right? I feel like it kind of puts it in perspective in terms of what is the impact of nanoseconds or these very minuscule amounts of time that's spent here versus the readability and the maintainability benefits.
And no matter how bad your code is never going to be as resource intensive as Bitcoin in the blockchain. So there's your scapegoat. Just think about that.
Well, there's that. There's also, like, to your point, Jason, like, you know, where's the cost? Like, is the cost on how many CPU cycles we're running and how long that takes versus how many human CPU cycles does it take to read the code later? Like, that's what you want to try to optimize for that first, because that's by far the most expensive thing in your project is the human CPU cycles that are being burnt.
Yeah, for sure.
Yes, Jeremy, blockchain is literally just a bunch of distributed loops that have been split into, just iterates over itself over and over again.
I look forward to furious emails from blockchain enthusiasts here telling us that's not really where it goes at all.
Yeah, sure. I'm sure they could replace the entire blockchain with a query. No, nobody. Okay. I'm bringing it back to refactoring.
No, it's interesting because I mean, I totally hear Antonio and Jason that feeling is like doing this thing more than once. It's got to be wrong. And yeah, it's funny because I did some like a little exercise myself this week. I practiced split loop refactoring, and then a little bit later there was a place where I didn't have a temp variable. I just called the method multiple times. Replaced temp with query, and yeah, it reads well, but it's still like I felt exactly the same in the back of my mind. I'm like, this is not so good. But then, in terms of legibility, I think it was more understandable. Yeah.
So you did split loop and you replaced temp variables with queries, and you're still here, and you made it all the way to.
I survived.
Sunday.
I survived, right? Yep. I still have the scars, but thank you. No. But to bring it back to this one, I really like the split variable example in this chapter, and reading how to do it, it was kind of like an aha moment. It was like, this is so simple, yet I've never read. I couldn't remember this from the first time around. Just the mechanics. It's just like, well, just change the name the first time it comes around, and then assign it to a new variable. And keep changing that to the new name, and then when you hit the second assignment, leave it as the old name, and you're done. Or just do this again if it's assigned again further on. Yeah, because I mean, I do see. I mean, I think we all probably see that a lot as well. That variables are just reused in multiple ways in methods. So I thought that was kind of brilliant in its simplicity. Maybe I just missed something. Maybe it's been obvious to all of you all along that this is how to do it. But
specifically for me, that trick, that trick about making the first instance const, so that you're forced, you know exactly, oh, there's another. This is the stopping point. There's another assignment. That's where I need to change it. I agree with you. I think it's a nice little trick. Yeah,
I do, and I was reading that, and I'm sure I see it, but I was trying to think like when was like in a recent time, like when did I do this? I was trying to figure it out. Like, but his methodology does make a lot of sense, and I think it's cool. But I don't know. I don't know if I see that one a lot, Jeremy. You said I'm sure everyone does, and I'm like, I'm trying to think. Do I see that a lot or not? I don't know.
I think I see it a lot. The most times I see it is in terms of assignment to an input variable, or reassigning an input variable. And I know like IntelliJ is very good about warning about that. So I'm quite used to seeing that in the code, but I don't think IntelliJ actually hasn't got a built-in refactoring for split variable, as far as I'm aware. So just knowing those mechanics is a really good one for me. And I liked his discussion about, when the variable, the input variable is an accumulator of some kind.
Yeah.
You know, then it kind of makes sense.
That one's tricky. Oh, go ahead.
Oh, sorry. Yeah, I was just gonna say at first I kind of agree with you. Like in the first example he gave, it was very explicit, and I was like, I don't know how often I do this kind of reuse, because I think just I look at that and it kind of already smells bad when I see that. But then there was a subtle thing later on in the I'm looking for this section now. Yeah, in replace derived variable with query, where there was that, oh, I have this initial value for production, and then I also have the accumulated value of production from there. And at first I didn't even read, like when I looked at that piece of code initially, I didn't even see the fact that, oh, actually there are two different values of production here. Like one was the initial and one was the kind of accumulated. And then so then when he was handling that case and he's like, well, first I would split this because these are two different uses. And I was like, oh, you're right, those are two different uses. So I think there's more subtle things that don't stand out to me day to day that I'm probably missing.
When I first, go ahead, Jeremy.
Oh, I was just going to say from a Java, what's nice about this example being in JavaScript is that you've got let and const, right? And so you see an assignment to a variable. It makes me think that, you know, there's cases, he spoke earlier about like assigning the variable at the time you actually use it too, because I think it probably helps you look for this scenario, because otherwise if you're just like assigning an empty variable up top and then you go and assign it later on, you see this and you're like, oh, did I reassign this? And now you have to think about it again too. So it kind of calls back to that old refactoring from the earlier chapter, which is really nice. But I see this a lot in non-JavaScript, like in PHP, which is what I work in. I see this a lot in code that I work on, and I try to judiciously like eliminate it as much as possible, because it is hard to follow, because you're like, oh, okay, what is accelerate? What is accumulator now? What is the value of it now? And versus like if you have a name for everything, then it's just easier to read.
When I first read the split variable thing, my motivation was, I misunderstood the motivation. Like I felt like it was going to be something way more profound. I was thinking more about like contextual. So for example, let's say you have a human object, but then in different parts of your code base, that human could be, I don't know, a waiter, and then in another context is a cook, and you know, it's like the contextual of what's happening with that object, and like making sure that your naming convention, and like even if it's on the same function, like maybe having a second variable that makes very clear what the context of what's going to be happening with that object is, even if it's just a copy. Which I guess you could interpret it as that, right? Like there is a renaming of the variable, and he didn't go too deeply into like, well, make sure that your variable is contextually named so that the new information it's there, even though he does mention that in other parts of this chapter. But yeah, so yeah, I was thinking more in those terms, but it all works all the same. And sorry, Bernard, I interrupted you.
Oh, you were first, no problem. I was just going to say for me, when this stood out, when I've done this, and this is going back very early in my career, it depended on the language. It was when I used C a lot, and in C at the time, at least, you had to declare all your variables at the top of all your methods or functions. You had to. And so what people often did is reuse them, because maybe, you know, they wrote some more code and like, oh, I don't want to declare another integer. It's just another for loop. I'll just reuse the old one, right? And I think it made a lot of sense too when you're using C to work in things like microprocessors, because even memory management is important too. So it's easy for, I think, him to say, you know, in modern languages, you can declare const and, you know, you should never do this. I think in the old days, you probably had to. And this is just my experience, maybe even before that, like you were almost forced to. So I think it's easier for us to do it now. I don't see it happening as much because I always inline declare everything. Like, why would I declare it at the top and reuse? Like, there's no point. So I don't know if it's just maybe older programmers that have bad habits from the past, but yeah, I don't see this happening. I don't recall the last time I've seen this recently.
Actually, there was a case this week when having a variable not declared near where it was used actually bit me. I was working with a colleague on doing some pair programming and some refactoring, and we were trying to extract a method, and IntelliJ was just going like, yeah, I can't do that. There's multiple exit points. And we were looking at the code, going, well, where is it? And then about 10 minutes later, we realized that a list was being declared 15 or 20 lines higher that was actually then used in this chunk of code that we were working with. Sorry, I can't let you do that, Jeremy. Yes, there was this flashing red light, and yeah, I then had to, explode the doors of the capsule. But no, it's funny because and it's not something that was super obvious to us at the time. But when we saw it, we're like, this is crazy. And when we found the line, IntelliJ was saying, oh yeah, I can move this line closer to where it's used for you. So we, but yeah, it's an interesting one.
When it said it could move the line closer, did you say, why didn't you lead with that instead of this whole charade about how you can't do it? Like, you should have just led with, hey, I can move that line for you if you'd like. And then we get to it.
Yeah, that should be that should be a feature request. It's funny because it actually IntelliJ does show you on the line where the variable is declared. It says to you, by the way, you can move this and make the declaration closer to where it's used. But on the place where it's first used, it doesn't tell you that the declaration is 20 lines above. So it kind of feels like there's a little feature request I should put in for JetBrains for that one.
Nice. What else?
And then we come to rename field. That's the only one we haven't talked about.
Did you get a lot of mileage out of that one?
I thought his process for how he got there was great. The whole throughout the book, he's been talking about make a small change, run the test, make sure they pass, and that's how you get there. So again, it's like another great example for how you get from point A to point B through those small iterative approaches.
Yeah, the part that stuck out to me was when he had like, oh, now I've added this so it works with both, and I made the change, and then I ran all the tests, and then I go and I remove that once I see everything that's working. But it's something that I previously would never really do. I would just try to make it all work with that, and then if I run and if there's a compile error or something, then I find out what I missed. But it's something that I've been practicing as I've been doing refactoring more recently, is this like make the tests always pass and do these extra steps to make it backward compatible temporarily while I'm changing things. And I do find it's definitely more, makes me more confident feeling when everything continues to work.
It is helpful. I think that's the big thing I've taken out of just reading I mentioned this earlier, but like just the methodical side, like trying not to skip ahead and just kind of going through the steps. And there is actually benefit there, even though it seems like you're adding extra process to your own work. And I think probably early on I was possibly, halfway making fun of, oh, I changed one character, I better run the tests. But like, I think there is a lot there that's, in the space of putting in even, logs or tombstones for things that you're moving around, like just kind of things that, yes, you have tests that, hopefully you have tests that you're running, and yes, they'll catch a lot of stuff, but then, compilers also help when that's available to you, or even just putting in that extra step does expose things that you were like, oh, I didn't catch this with my search and find or find in files or whatever, because I clicked the wrong directory, or which I've never done, but I've heard it happens to people. So yeah, better there than in production, right?
It's funny, to Jason's points, I highlighted a sentence in this passage that I think sums up exactly that. And he said, smaller steps mean fewer things go wrong in each step, therefore less work. It wouldn't be less work if I never made mistakes, but not making mistakes is a fantasy I gave up on a long time ago. Particularly that last bit definitely strikes a chord.
I don't know. I've been doing this for over a decade. I've never made a mistake before, so don't plan on starting now.
We need to hire you, man.
No, because then I'll make mistakes. It's like, nature of, right? Yeah, no.
I look forward to hearing about, now you said it out loud, all the mistakes you're making in software in this next week. You wonder what's hit you.
Nice. Cool. Anything else?
Little question. When was the last time that any of you realized that one of the column names in one of your databases was awful, and so you actually went and refactored that column name to put better understanding into it.
Probably a week ago.
Wow.
I do that a lot. I've also done giant PRs to reorganize database like column orders because stuff drives me nuts sometimes. But yeah, I mean, I think I mentioned this last time, but like we, had a code base where something was named something that was just drastically wrong. It didn't make any sense, and just the cognitive load required anytime you wanted to think about it. So like that's like a thing that if there is an opportunity, like I can go through and it's not going to be detrimental in some capacity or like make 3 weeks of work for me to go and change the name of something, I will absolutely do it whenever I can. And I've recently done it. So anyone else done it? Nobody.
I've advocated for that at least in the past, where I join a new organization. What does this thing mean? And everyone has their own version or story. And then I say, like, why don't you just rename it? It's like, well, that's impossible. Like, that's too hard. It's too much work. And so they just leave it alone. And every time they introduce new columns that are similar, they use the old name. They use the confusing name because now it's consistent, which, okay, I can understand, but you're just making the problem worse.
I've been on both sides of that, right? Like I've been on the part where in the database it's wrong, but then in new code that was written after a certain date, it's named the thing it should be. And then an old code that was, and it's just like, you do realize that anytime you have to work on this, you have to go trace through and figure out like, at what time period was this written? And I should call it this here. And it's a lot less, yes, it might take time, but it's a lot less work to onboard new people and go through the history lesson of why things are named poorly than it is to just buckle down and make the change. So do it. Be brave.
I'm trying to find an image of like one of those, when you watch like a crime scene, they're doing or a crime show and they're doing an investigation. They've got that board up with all the threads tied between them. That's like what we're talking about here. Exactly
like that. Which coincidentally is also how my son's room looks when he's doing his school during the week. Like he's got papers all over the place. And I'm like, dude, what are you doing? He's like, well, that's for my science project. I'm like, okay, whatever. I don't know.
Yeah, I think it's the whole data model thing. It's interesting because it's so easy to not do it just because we have so many layers in which we can, like you said, like you can just fix it at when the data comes in, just whatever is wrapping that data, just make it have the correct name. But I also, this is kind of like 2 steps away from the point that I'm trying to make. But like 6 months ago, I decided I'm gonna go and record every single bug that I find during the next few months to see what it is connected to. And like 90 or 99% of them were all connected to the data. It was never like huge logical problems. It was always like data was just borked in some place or something was named weird or somebody did something. It's by somebody, I mean us. I mean, we're the only people doing it, but it's easy to blame it when it's happening somewhere else. But yeah, anyways, it was all data related. But it's at the same time, it's just like, it's so easy not to pay attention to it. That's why this chapter is so short. There's so many few things to do, but
yeah. I think that point is interesting because I think it may have been last time or time before, he had some sentence about like how there's so much code written to like just fix things in process, like what you're talking about. Like it's, in your code, you're handling poor decisions in the model. Like the data model is like data structure, the most important part, because if you get them right, you have a lot less code to deal with all those inconsistencies. So yeah, I think it is interesting, and maybe that's why I'm so like pro, changing the data model and not just fixing it in your transfer layer or whatever, like whatever you have, like not fixing it that way, because that, yes, it works, but then there's going to be situations where someone doesn't go through that for some reason, or they're writing queries in something that's fixing it. So now they're interacting with these poorly named things, and then you're having to look at that in 6 months, and you're like, well, why is it called that? And like, you just, every time it's, you know, it's that whole 20 milliseconds that Antonio was worried about, but now it's 20 milliseconds that are in your brain instead of 20 milliseconds that are on the CPU, and I'd rather put them there. So just, yeah, I think it's important to do the hygiene. Like I would call it like data model hygiene. Like just as your code has evolved, your data model will likely also have to evolve. So now, has anyone written unit tests for their data model? That's the question. Who tests their data model? How do you even do that?
JSON schema.
Oh no, we've gone full circle. That would be it. Did we talk about, Jeremy, I think you mentioned like refactoring databases as a thing.
Yeah. Because I mean, I'm totally with you on changing the names on these things. The problem I see a lot of work is the sheer volume of data that we have makes those changes slow. So therefore, doing them becomes a huge multi-step process. Like one of the principles of our deployments is that downtime to customers should be as minimal as possible. And on some of our busiest tables, the amount of data means that even changing a column name takes 20 minutes. So it's not impossible, but it's knowing the steps of how to do it in a way that doesn't, you know, mean multiple hours of downtime for our application is the trick.
In MySQL, Percona Tools online schema change is your best friend for those situations where you have gigantic data sets, split table. Those are always fun. Like I remember building a continuous delivery pipeline, and so it was like all the migrations for like 5 or 6 different apps that we had were all handled through this one project. And so you'd end up with, you know, your releases would be spread out over, you know, 10 different PRs, because you're like, oh, wait, add something here, and then we copy the data. Then we have to deploy code in these 2 projects, which writes to both columns, and then one that like does the transfer and does like the ETLing to the first like new column, like just all this, and you end up with 3 days of deployments, and at the end you're like, it looks nice though. I mean, it's in the right spot in the table, and it's named what I like it to be. It looks nice, even though I spent half of my life doing this one deployment. But yeah, I think it's a cost for sure, like the timing, but if possible, it's worth it. I think I'm still going to err on that.
Yeah, I should really read the refactoring databases, but as you were saying that, I was thinking it seems to be the database analogy of refactoring code. It's like tiny incremental steps. Each one takes you a little bit closer to your goal until at some point maybe you can finally realize all of the value.
Except instead of running unit tests, you're deploying your entire app.
And hoping for the best.
Yeah, I've seen that. So I come from the world of Drupal, and for those of you that are familiar with Drupal, like they created their table structures to make it very easy for you to kind of like create your models from a graphical user interface. And so you're able to like add fields randomly and delete fields and all sorts of things. But this is not a simple problem. So obviously, after you set up your initial model, like if you decide to modify the type of a specific field, that is complicated. And so I see this paradigm in which people just so over-engineer the data model. Like they just spend so much time just thinking about it because they're so afraid of having to change it later on. And that causes all sorts of bad general practices moving forward. So yeah, I definitely think that's a problem we need to solve. Like changing your data should be as simple as refactoring your code so that you never feel uncomfortable having to do it for the right reasons. And I feel like a lot of us are in that position right now. So
Funny, there was a lot of you might know Mark Story, who used to work at FreshBooks, and he's spoken publicly about this story, so I feel comfortable sharing it. But at one point, FreshBooks, I mean, they ignored the technical debt in their database. And I believe when new customers signed up, instead of having multi-tenancy tables, they literally made a new set of tables for that new customer with a different prefix in front of it. So when FreshBooks got popular, they suddenly found they had over 1 million tables in their database. And at that point, they were literally at the point that if MySQL shut down, it may not have been able to start it up again. So they literally, he said for a while in their office, they had a sign up in the wall that the number of tables dropped this week. They literally had to just go through and combine all of these things into multi-tenancy tables. But they survived it. They did it. They refactored the database. Mark has spoken about this at conferences, so I'm not sharing anything proprietary there. Yeah, but they're kind of an example of how this stuff gets out of control.
And how costly it could be, right? Like maybe at first it was like, oh, this makes sense. Like we only have a couple of sets of tables. Like, well, now you've got the n+1 problem, like in your actual tables. Like it's kind of crazy. I guess you have one table that lists all the people, all the different prefixes that you could have, and then you have that number of tables for all of them. That would be kind of crazy.
Yeah, who knows? But it speaks to the kind of thing as well. I mean, I'm sure when the first people did this, either they didn't know better or it seemed like a good idea at the time. And then there's a period of time in which you can actually make that change fairly easily. And then after a while, the change gets so difficult that even when everyone's going, this is a really bad idea, you just keep going with it because the cost of making it better. And then, maybe there's something there about, for all of us, about the cost of technical debt. Like there's always a period in time in which, I think Michael Feathers writes about this, that, for a while, there's a period in time in which you could make the change, but people don't tend to do it. And then afterwards, people can't see the code being structured anyway. This is just the place where you put all the data about all the customers or about all the employees or whatever it is. And at that point, making the change is supremely difficult.
I think that period of time is the period in which it's easy to say, oh, we don't need to do this right now. The period of time when it's easiest to make the change is the period of time when it's easiest to say, well, no, it's fine for now.
Yeah, and until it crashes, it doesn't bring any benefit, right? And you are always competing for some other problem to solve.
It's until you hire the next person you need to onboard that needs to work on it. And then it's like, oh, well, now I have to explain this to them. Wouldn't it have been a lot easier if I just fixed it instead of having to write 10 wiki pages to explain why this thing is named poorly? Yeah. So I guess the takeaway there is technical debt eventually reaches technical bankruptcy and then just delete the whole thing and start over.
At that moment can be very late, right? For example, the whole Adobe kind of login password,
Yep.
I don't know in which part during this chapter inspiration struck, but I wrote something a little bit about this in Twitter, but I was thinking I often choose to do the quick, easiest thing because I have so much faith on refactoring and tests that I'm later on, I'll just go and make it better. But I'm starting to think that maybe that's not the right way to do it. It shouldn't be well, I'm going to throw the trash in the floor because I can pick it up tomorrow. And I know I have the tools. I have the broom and I have the thing, but it should be more I know that this is not good. And right now I have the right context to keep things clean and maybe even make it better. So I'm kind of violating two rules, the rule of yes, you can do any refactoring anytime, so don't be scared of making the change, that's a thing. But at the same time, it shouldn't be I just do bad things that I know are bad just because I know I can change them later. That also sounds incorrect, and it's against the Boy Scout rule or whatever of always leaving your code base a little cleaner. So if you know better, just don't think that you can make it better tomorrow. Just keep it better and keep it good today, which I haven't practiced, but I'm going to try. I'm going to try to take the time.
Yeah, I mean, I think there's a lot of value in the MVP approach, but I don't think that we should apply that to code so I guess hopefully I'm understanding what you're saying correctly, but you do the thing that gets the job done, but if you know that it's not it's only understandable to you at the present time, and you know there's a way to fix it, you should do that. And then that should be your stopping point, not just it works and it's there and, hey, I just need to get this out kind of thing. Yeah. I think I agree with what you're saying there. Yeah.
I see this most often when you're adding new features, because usually for you to support some new piece of functionality, you kind of have to like make your whole model more complex. And there is always a way that you can kind of like keep those things separated so that you're not sacrificing the simple path for the more featureful path. But I often don't do that. I'm like, okay, later on, I'll come and clean it up and I'll make sure that I have proper separation of concerns around these things. But I never go back until I think this is the connection back to the whole technical debt, until it's like, oh crap, all of these parts of the system are utilizing this more complex modality. And now it's really hard for me to abstract back the simple from my system. And so now the simple is impossible. And I think that's always a bad pattern. If your system just continues to get more and more complex, you're probably not refactoring correctly, I will guess.
I've seen that a lot of times though. I mean, I think people talk about red-green refactor, and my experience has been that people are great at the red-green bit, but we're really good at going from this doesn't work, now it works, but we're really bad as a whole at the refactor piece. Like people are just like, okay, it works, what's the next problem? Yeah, it's interesting.
If it's not broken, don't fix it, right? That's what we've been taught. So red, green means it's not broken. So why would you fix it? Yeah, I mean, I think it boils down to like, I mean, I think you have to be cognizant of, like I can count the number of times where I've pushed something and been like, oh, I know this is bad, I'm going to clean it up in the next ticket or whatever. I can count on my hand probably the number of times where I've actually cleaned it up in the next ticket. So I think it's at a point where, like, if you know that there's something you can do to improve it or to make it easier on everybody, and not add to-do comments in your code base. About to-do, like I've worked places where we've been like, oh, you have to put your name with the to-do comment. That way we can shame you without like needing to get blame or whatever. That also doesn't work. So like that's not a viable strategy. Like if you're putting in a to-do comment, either do it or don't do it. Like there's no to-do. Like just drop that whole practice. I can't stand it. But anyway, like if you know that you can make a change that will make it easier to understand or better, or not pile on to the hoard that you're building in your, like we need to make like a show for like hoarders buried alive, but it's like technical debt focus. Like let's get on that. We can work on branding after this. But if you know that it's going to make it so that other people have to commit bad things related to it, fix it then. But if you, I mean, it's not saying that you have to, every time you code something, go through the book and look at every refactoring you can come up with. Like, I don't think that's the right approach either. Like, I think it's that thing we've talked about over and over again in these chapters, which is, what is the point where it's understandable? Like, get there, and then get to the point where it's understandable enough that I know that it's not causing harm to the future of this particular module or whatever. And then that's quote unquote good enough, right? Like you're there. It's not quite MVP. It's not the first thing you wrote down, but it's also not an example that we're putting in this book as, hey, this is how you do it, right? Jeremy's thinking about the title of that show.
Yeah, there you go. I've been reading about some things about this related to software architecture recently, and people, saying pick, good enough architecture was the title of a presentation I saw, or so in a book I wrote was a satisficing. Somebody invented this word to be like, or another one was pick the best, least worst architecture, right? But is there some heuristic here for how to observe that in code? How do you know when you've got the best, least bad solution? Like it doesn't always have to be, all singing, all dancing, bells and whistles. It can be good enough. How do you know when you've got there?
I don't know. I mean, I think the answer in there is like when the, that old XK CD about the WTFs per minute or whatever, like it's when someone else reads it and they don't have a lot of like open-ended questions. Like, what is this about? Like, why did you do this? Why is it called this? Why is it here? Did you think about putting it here? I think that's the answer. Like if you're on your own in the project, yeah, I guess you have to improve your acting skills and pretend that you're somebody else looking at it for the first time, or like go take a walk and come back and look at it. I mean, that's kind of my general approach anyway on code that I'm pushing. Like and I do this a lot, like I'll open a PR, but then I'll go do something else and then come back and just read through it myself. Like before anything else happens to it, just read over it and say, does this still make sense to me? It's like that whole, yeah, I thought I was a genius the first time I wrote it. Then you come back and you're like, oh, that was actually totally wrong. And then, so I fix things a lot, like in a second wind of a PR. So I think that's like the answer, right? Like it's when you've taken a step back, erased the context out of your brain. So you no longer have like I had the whole problem in my head at the time I was writing this, and you've now looked at it again and it still makes sense. That's good enough, I think. So no, I don't think there's like a concrete heuristic you can use. I think that's always going to be subjective.
Yeah.
My heuristic is similar though. Like I always, like when somebody asks me about something, especially somebody that is not maybe a developer, or I mean somebody that's technical but not necessarily like in the code with me, and I explain the thing that this system is supposed to do in a way, and then I can go look at the code and I see that identifying the code, like these things, how I describe it, makes sense in the code base. Like I feel that should be good enough, but I'm sad to say that most of the time that's not how it works. Like I go look at the code and it's way more complex than in the way I'm describing it, and that's what I'm talking about, the simplicity concept. Like there is no good reason in my brain why the way I describe these things to you should not be represented in the code, but often it isn't. And yeah, I think that's where the failure is, and I wonder how I personally can get there.
Live code readings. I think that's how you get there. Like the old school, like the old school reviews, like you have like the whole ceremony or whatever, you get together like on every other Friday and you just I'm going to walk you through line by line my PR. And this is why I did that. Coding the round.
For some reason, when you said live code readings, I was like a poetry reading. I was like, who's going to pay to come and hear this? That would
be fun. You could do like the whole snapping thing. Like, oh, look, he got rid of that for loop. Snap. No, nobody. It'd be the next thing on like America's or Britain's Got Talent or whatever, right? Like live code readings. Judges like, oh wow, that was amazing. Never seen anything like it before. You use split loop and you renamed a variable. Well done.
So much clearer to me after you did the refactoring.
Yeah. Yeah. All right. Anything else? Any last words?
One point, English is obviously not my first language. It's a little bit too anecdotal, the way he writes. More like, okay, these are the things that have occurred to me regarding organizing data, right? And I guess that's intentional. Sometimes it's a little bit too much, but yeah, it seems like, okay, these are the things I have found, but you can find more, I guess, right? I don't know, how do you rate him?
Yeah, I mean, I'm gonna say I think it would be hard to, without having a 4 million page book to like kind of cover every potential scenario. I think is what you're getting at. It's like I mean, this chapter could probably be super long depending on how you classify things. And I think just reading through it, his first book, and I kind of remember this, but like if you look at some of the, like at the beginning of each refactoring, he says like previously called these 5 things or whatever. And like those were all individual. And so I think he probably in the second edition realized that when you bombard somebody with a catalog that's 800 pages wide or long, that it's not useful. Like there's no way for you to contain all that in your head, like reading through it. And so if you're trying to read this front to back like we are, it's really challenging to get past the whole, I need to have examples that make sense, that are small enough that you can understand them and fit into this paradigm of these grouped refactoring. So yeah, I mean, I think it is anecdotal, and I think it probably always will be, in the sense that like my experience is going to be different than yours and what I've seen. And so like I may see the temp variable, like inlining things, I may see that differently, or it may trigger some other refactoring that kind of fits in the same pattern. So I think what he tried to do is just distill it down into, hey, I've seen these particular problems, and then here's some solutions to those. And then hopefully that will spark in your mind, oh, I've seen problems that are similar in presentation, maybe slightly different, and they combine into these things. So he's trying to take a very complicated subject. And I know we talked about this before, but like it's every one of these kind of in standalone fashion is very simplistic and seems very, oh, why'd you write this? But then when in practice, it's often you're doing 5 of these at once. And so I think it helps to have the smaller anecdotal, this is one thing that I've seen. And I mean, I don't know that this is actual code that he's ever seen in real life, or if he just made it up to fit the particular refactoring. But I think it's helpful to have it in this form because it's illustrative of the example without a lot of extra context that you need to be aware of. So, I mean, I think I appreciate it from that standpoint.
I also look at it in the same way that I look at religion. Like people tell me like, hey, come back to church. And I'm like, you know, those first 10 rules that you told me the first time I went, I still haven't mastered those. So I don't know what it is that you're going to tell me that I'm still practicing those 10. So I think I'll wait after I master them. Then you can tell me about a few more rules and then I'll go from there.
You're waiting for the second edition.
So now we're going to have comments from the blockchain people, from some religious people, just making it controversial.
Yeah, this is going to be the most controversial episode yet.
Well, we did it. We made it. Made it all the way to chapter 10 without bringing the hammer of the internet upon ourselves. So well done, you all. All right, I think we're going to wrap that one there since we got through the religion argument. We're now in the Church of Refactoring. So we'll wrap it. Thank you all for your participation tonight. Next week, we'll be going over conditional logic, which is my favorite thing to obliterate it in code because it hurts my head. So should be a good chapter. I'll see you all next week. Thank you very much for your participation tonight.
See y'all.
Thank you.
Good night.